A tangent and a radius are perpendicular at the point of contact. So a tangent to a circle meets the radius at 90 degrees is what this is saying. I can show you that with an animation as well. So if you look here, you've got the tangent going all the way around the outside of a circle. The tangent's just a line that touches a circle at one point and one point only. And it doesn't matter where I draw that tangent, it always meets the radius you can see at 90 degrees. It doesn't matter how much I spin this round, that angle is not changing at all. So you have to work out the size of the angle marked X. So these ones I think are the easiest in circle theorems because you've got the tangent's obvious. It's always a line outside the circle and it always touches it at one point. So as soon as it touches it, as long as it's touching the radius, which we can mark on as R, we know that the place it's touching it is 90 degrees. So I've now worked one angle out in the triangle, but I've already got another one. So angles in a triangle make 180. So I can do 90 plus 39 is 129 degrees. So X is 180 minus 129, which is 51 degrees. Give that a go yourself with this question and come back when you're done. Okay, let's go through the answers to that one. I'll zoom in a little bit. So again, we'll always look to see, we've got a tangent. Is it meeting a radius, which we can mark as R? If it is, then this angle here is 90. So X equals 90. We've got one of the angles, and the other angle in the triangle is already given as 43. So since angles in a triangle add up to 180, we can do 180 minus 90 minus 43 to get the other angle. And if you did that, then Y would be 47 degrees. Okay, hopefully you've got the idea of that by now. Have a look at these questions and give them a go. Pay particular attention once you get to ones like here. The whole angle is 90, so if you've already got a bit of it, you can add up the rest to make 90 to see what's missing in here. Also notice if you zoom in, the little dashes on the line are telling you they're the same size, but you should be able to see that because of the radius. So you might want to look at our previous video where we made isosceles triangles if you're unsure of what happens when you get an isosceles triangle and what the angles would be. Otherwise, give these questions a go and come back when you're done. Okay, and the answers. Let's go through this step by step. So question A, there's my radius, there's my 90 degrees. So A is going to be 39 degrees because angles in a triangle are up to 180. Question B, there's my radius, so there's my right angle here. But since it's noted that these are the same size, that's an isosceles triangle, so they must be the same size, which is 45 each to make 180. So B is 45 degrees. Question C, there's my radius, so there's my right angle, which means the other side of it is also a right angle here. So if I do 90 minus 56, I get the size inside the triangle, 34 degrees. Since this is an isosceles triangle, this one here is also 34 degrees. I've not even needed to work out this one up here, but you could if you wanted to. And the last question. There's my right angle because there's my radius meeting the tangent here. So therefore the other side's the right angle, so I do 90 minus 62 and get 28. So it's 28 inside the triangle. 28 over here because I've got an isosceles triangle here. Angles in a triangle add up to 180, so if I do two 28s I get 56, which leaves 124, so B is 124 degrees. Let's continue on with our tangents and see what happens when you've got two tangents getting drawn. If I draw two tangents from a point outside the circle, then the lengths of the tangents will always be the same size. It should be obvious just by the look of it that that is true, but I can show you that with another animation. You see here I've got one point, and if I move that point in or out, it changes the size of the tangents, but once I've stopped, the tangents are the same size. It's obvious that that's the same size as that. It doesn't matter if I go round, they're always going to be the same size. And that's important because we can then draw triangles or other shapes and know that two sides are exactly the same size to start with. So using that knowledge, it tells you that AB and AC are tangents to the circle. It tells you the length of AB. Can you write down the length of AC? Pause the video here and give it a go and come back when you're done. Should have written down that since AB is 12 centimetres, AC is also 12 centimetres. It's as simple as that. Question 4. AB and AC are tangents to the circle. It tells you the radius is 7. You have to work out the length of AC. And you've also to work out the length of AO. Pause the video here and give it a go and come back when you're done. And the answers. So AC is obviously 24 centimetres. That shouldn't have been a problem because we've got our point way out here, tangent up here, another tangent there. So they're both the same size. It then says work out the length of AO. So let's just check what AO is. AO is this length here. So we need to start identifying angles and see what type of triangles we've got. Okay, so if I look at this triangle here, that is a right angle triangle because a tangent meets a radius at right angles. So since we've got a right angle triangle, if I draw that out, we can use Pythagoras. We've got 24 here, 7 here, and then there's my length OA here, which I'll just call X. So by Pythagoras again, we can say that 7 squared plus 24 squared equals X squared. 7 squared is 49. 24 squared is 576. So X squared equals 625. So X is the square root of 625, which is 25 centimetres. And it's been Clelland Maths, and today we've looked at tangents to a circle and we've seen what that does, and we've also looked at two tangents coming from one point, and remember a tangent means a radius at right angles. Thank you very much, stay safe, take care.